Hi, everybody. Hope everybody's doing well. Today, we're going to take a break from the norm of actual copper construction. I don't know what that white spot is in my mustache, but I promise you it's not a booger. And we're going to talk a little bit about thermal expansion today. So, behind me, I've made a machine that actually shows thermal expansion, and we'll get into that here in a little bit, but you can see the ruler. Got to get closer to my head right there. That's part of the machine, and I actually have a demonstration that does show it. Now, this machine, so I'm being honest with everybody, does amplify the movement about 50 times, and we're going to be heating the copper rod in this machine higher than you would normally go with a still. So where this actually applies to a still, in a half of a sheet of copper, 60 inches wide, if you heat from room temperature to boiling, it gets about a half of an inch. Gee whiz, I'm adding to this. It gets about a 1/16 of an inch larger. The bottom only grows 1/3 of that. So what ends up happening is the sidewall, if the bottom is put up inside especially, the sidewall grows faster than the bottom, and eventually it pulls itself apart. Now, this is most applicable to where when the bottom is soldered up inside of the still. If the sidewall is sitting on the bottom and soldered, it's not going to cause an issue as fast. If this bottom is actually folded up over the sidewall and there's a lip folded out on the bottom of the sidewall, then it actually will lock itself together, and we will get into that more in construction. So only about half pay attention to what I just said there. So that 1/16 of an inch movement, where copper is a forgiving metal, you might get by with it for a few years, but eventually it's going to work at that seam where it's butt soldered on the bottom and pull that seam apart. There's a picture floating around on the internet right now. I shared it and actually shared that 0.000098 knowledge of knowing what that number means would have solved the problem. Well, that 0.000098 is the coefficient of thermal expansion. That is, copper moves that distance when heated 1 degree per inch. So when we go up, in the case behind us here, we're going to go hotter than boiling water. When we get up around 500 or 800 degrees, the copper's got significant movement, and that this machine will show it. And I realize it still doesn't show it that much, but it's something that needs to be factored in as you're building. Now, over the years, I've brought this up, and I've fought with people saying they need to change their still bottoms and whatnot. It's getting to the point I'm not building as many stills as I used to. My health is going to force me to stop here before too much longer. I'm sharing this information so the people who want to build their own stills, or builders who truly care about their customer, can change what they're doing and make a better product. The picture floating around right now on the internet shows a still that likely had thermal expansion in the side. It pulled apart, and then as it come back together, the bottom poked down a little bit, and it's got like a 1/2 inch gap. Now, if that happened in somebody's kitchen and that thing was full of scalding water, the still builder is now liable for the still, the possible damages, especially to a glass top, maybe stove. Hopefully no pets or kids was around if that thing sprung a leak indoors. And that's why, though, this needs to be brought to attention. When it happens, sometimes you're going to get lucky and it's just going to be a drip that comes out of the still, just a crack at the seam. Sometimes you're going to have something that looks like that still, the picture that's been floating around. I wish I had a picture of it here. I should have had one ready, and I'm sorry I didn't. But, if it goes to that extent, that's getting kind of dangerous, scalding water going everywhere. And I just want everybody to be safe. I don't want to see anybody get hurt. And it's such a simple thing. People have tried to argue with me over this over the years instead of fixing the problem. I mean, they've threatened to remove me from the moonshine community. They've ganged up, 5 or 6 of them to discredit me on this. So that's why my friend Scott and I, and thank you, Scott, for helping me build Disc Traction. We put Disc Traction together, though, to show you how it does affect copper. Well, not necessarily how it affects copper, but how copper does expand, and you guys aren't taking this into consideration, and you need to. So from here, I'm going to go ahead and explain this machine briefly to you. It's a very simple concept. And then I'm going to go ahead and take a torch and heat the copper rod in the machine and let you watch the needle move. Now, I guess somebody could give me the argument that the torch isn't hot or whatever. I don't know. But if you don't believe the torch is hot, you're welcome to come over and stick your finger in my torch anytime you want. We're going to heat it. I don't have a way to measure the temperature. This whole thing was more about just showing the concept more than measuring of how much movement you get. But I can tell you that we're going to take the copper up to, it's somewhere between 500 and 800 degrees. So I guess now we will describe exactly how the machine works. Excuse the crudity of this. We threw it together out of scrap farm implement parts in about an hour and a half. Turn the camera a little here. So what we've got, just a needle, and I just threw a ruler up there and set it at about 10 so you got a point of reference. Here, it's kind of hard to see, but you've got a screen that pulls that needle back as it starts to move, so it stays tight against the copper rod. This is the copper rod. See, I say it's a copper rod. It's actually copper tubing, 3/8 copper tubing. I pulled it out straight, hammered it out on the bench so it's a little bit more rigid. That sets in a couple of grooves on some standoffs here. And I've moved some stuff around. Let me readjust here. Beautiful. So now we're back at the 10-inch mark. We've got the rod installed. The piece of copper in back here is just a blast shield, so I'm not putting direct heat on that particle board in behind. So now I'm going to move you a little closer. I'm going to be using this MAP torch to heat this rod. I will try to keep all of that in frame, but you will watch this needle up here move. Sorry, everything's backwards on camera. You will watch this needle move towards the 11 and 12-inch marks. There you go. You're right on 10. I realize that this is kind of hard to see. I got to pull it back. So we tried to have this to be 36 times amplification of movement, but what ended up happening is our rod sits a little higher on these standoffs than we meant, and I'm just leaving it alone. The actual amplification of movement is about 50 times from this needle. So now we're going to heat it up. Turn that down a little. We're going to call the first pass 150 degrees. And you can already see that needle starting to move. Now this pass is going to be a little closer to 300 degrees. Now we're going up to about 450. Now we're in the 600 area. Notice the copper's not really changing color. I'm just barely getting it hot enough to start to swirl. So that tells me we're a little hotter. I want to say we're at about 750 right now, and I'm just going to run back up it to even it out. We're going to call that 750-ish degrees. I realize the camera's not the greatest, but we started all the way over here at 10 inches. But overall, we made that needle move about 1.5 inches just by heating that copper rod. So, thermal expansion actually happens everywhere in metal. Most welders, it's a pain in their ass. It can work for you, it can work against you. Over the years in coppersmithing, and I'm not talking about my own experience, I'm talking about hundreds of years. The method that I do, the seaming that I do, is reminiscent of 200 years ago. Well, 200 years ago, they done everything the way they did for a reason. They needed that stuff to last. A lot of times people would bring their copper in and have the rivets we worked every couple of years, have it re-cleaned and polished. The more wealthy people, sometimes more often, poorer people, sometimes not as often. But they done everything they did because, one, they soldered with heat inside. They didn't have the handiness of a torch and being able to pinpoint a flame where they wanted. They had to put it over open flame in a forge, whatever, and solder. And the other reason is it had to be durable. It had to last. So, taking all of that into consideration and looking at modern methods, we end up, people will talk about using a harder solder, and they say that the bond is so much better. So a harder solder, a hard stick solder, looks like a brazing rod, melts at a higher temperature, and when you start getting to the point where you change the color of the copper to get it adhered together, you are actually weakening the copper. So those rods, they claim are stronger than the copper bond. Well, it's because they're weakening the copper to get there. Now, if you're using a thicker copper, it's fine. You could rehammer the copper back to hardness, because actually what it's doing is it's softening the copper, making it where it'll tear a little easier. But you can hammer back to hardness. A lot of companies don't take the time to do this. If you're looking at something that is put together that way, ask the company if they work it through an English wheel or do something to reharden the copper. But what it boils down to is, over this 200 years of history of coppersmithing, the methods, the tools have gotten better, but the methods, the seaming, it's still the same, folks. What they've done is still some of the best ways. Now, some of us do things a bit different, like I do a more English type dovetail, and I've seen other guys do the sawtooth type dovetail, and there's nothing wrong with that. That's holding it together so it doesn't fall apart when you're soldering. So our next video, this is a Friday afternoon. I wasn't actually planning on doing this video. Scott said, let's throw this thing together and show people what really happens. So thank you, Scott. Here's the video about thermal expansion. And on Monday, around 9 a.m., I'm going to go live on Facebook, and I might do it on TikTok too. But I am going to show exactly how we assemble stills here in my shop. And I'm going to tell you that this is the kind of work that you should get if you're paying more than $100 a gallon for your still. When I say that, a 5-gallon still, more than $500, you should be getting this quality of work or better. If you're getting the bottom shoved up in the bottom of a sidewall and soldered around, and you're paying $500 for a 5-gallon still, well, that's a place where two fools met, and that's all I can say. Because one, it's going to come apart, and two, you're stuck with it. Now, for those of you that have these stills and have had the problem, yes, you can resolder, and it's going to hold up a while again, and you just fight the leaks your whole life. You can actually unsolder the bottom out of the still and fold the bottom over with a pair of pliers, use a couple of hammers to work it straight, put the bottom back in and solder, using something to push it from the inside. If you can find a bigger piece of copper than the bottom, fold the bottom wall out and fold over like I do, and you'll never have to really worry about it. getting back into my video on building the still. It's probably going to go 2 days of live video to do this. If I have to go a third day, I will. I won't be giving the measurements necessarily, but I'm going to have a kit cut out like I would have in one of my still build classes. And I want to show you step for step of how we put it together. And in some cases, I'll explain ways that are better than my own. Like I said, I've been ridiculed saying everybody should do it the way I do. Well, that's because there's a right and wrong way. When I got into this, I wanted to kind of duplicate the, we'll say, Prohibition era moonshine still in Appalachia. So there's things that could be done that could be a bit better from the design that I typically use. And when people pay for it, yeah, I go ahead and do the further up designs. There's a lot of questions I want to get to in this, but they'd be better off answered in that still build video. So I'm also, over the next couple of weeks, I'm going to do a video of how to mark out a cape using a calculator app. And from there, I am going to start a step-by-step series of videos, more close up, of how to assemble still kits that we are going to start selling. We've already got cup kits on the market. They are $10 a kit, $10 for shipping, but you can put more than 10 kits in the, or more than, sorry, one kit in the same envelope. 10 might be getting a bit many, but we can get 6 or 7 in there pretty easy. So again, you could, if you wanted, you could have 6 or 7 cups for $10 a piece, and then one $10 shipping charge. Still, parts are going to be a bit more expensive, obviously, but what these parts will be hand cut parts with a lot of marks already made on them. Sometimes some cases there might even be a bend started. I got a piece here that will work for a reference. This is part of a cape. I go ahead and put the bends on. That way I know you're bending to about the same place I'm bending. Makes everything go together a lot smoother. With these still kits, if you're really interested, I'm afraid to post prices at the moment because copper prices are a little volatile right now. But if you're interested in a kit, let me know what size. They all go together pretty well the same. I'll get you a price on it and a price on shipping. And if there's some part of this that you guys are afraid to do, ask. I'll go ahead and, if you need me to put the cape together, I'll go ahead and put it together for you. I don't have a problem with that. Now, of course, it costs you a tad more in shipping and a tad more on my labor. But as far as me cutting these parts out, they're hand-cut parts. I don't have a lot of money in equipment. The edges are going to be decent, but they're hand-cut parts. So, you're going to have some filing to do here and there, a little bit of grinding, especially once you try to take my design, put it together yourself, because I'm going to do things a little different than you do. But these will go together. And I can offer the option, if you get halfway there and you can't get it together, you can send it to me and I'll finish it, or bring it to me and I'll help you get it finished. On that note, this video is now about 20 minutes long. I'm going to have to do some editing. But I'm going to get off of here and go back to beating on some more copper. Hope all you folks have a good evening, good weekend, excellent summer, and shine on. Let's make this a good year for learning.